Alright, looks like I'm making a video, finally. So anyway, technical problems, Linux. I was doing an update, and it froze. And then when I rebooted it, the hard drive was gone. Yeah. Linux really knows how to kill hard drives. I probably, fried good 5 or 6 hard drives using Linux. I mean, in ways that just don't make any sense. Like, how did it kill a hard drive? It's just no reason. I mean, just, so an SSD drive to boot, so nice hard drive. And of course, a year's worth of stored data that I didn't back up most of. So anyway, so I'm starting over. This is a 2 year ago version of it's actually Knoppix. It's not Mint. So it does seem to work. So we'll see if this actually keeps working and actually records a video. So that'll be a good test. And if it does, then maybe I'll keep using it. But it does have some, it has some bells and whistles that are kind of cool. I kind of like that kind of stuff. I have to admit, it's, I'd have something better on the other screens, of course, but everything's got to be updated, and you can't really update easily, so it's more of trouble updating. And Knoppix has all kinds of weird directories, so, it's probably a good hard drive killer, too. But anyway, just, I haven't had any computer issues for a while, and I've just gotten lazy and forgotten how to fix anything, and, so it's just, it was a really bad morning. Anyway. So I've had all this other work I have to do and cementing and all kinds of stuff and whatever. So just a bad timing all around. So if you sent me a recent email, it's probably a good idea to send it again because I lost all of that too. But anyway, so comments and then we'll do some Photon stuff. And we'll see if the video actually records. Yeah, it's still recording. Alright, Miles only has it half correct. He strangely forgot the 4 to the kinematic base. Pi does not equal 4, and he goes through this whole explanation, and you really don't need all this stuff. Because clearly what Miles Mathis was confusing, I'll just reiterate it to you, because you're going to use all this technical crap, all this complexity, and the issue is really simple. And it just has to do... Let's see if this actually works. It's visible. I gotta fix the resolution here and such. I'll get around to that. Anyway, so the issue is that if you do, if you measure pi by measuring something going around a loop, like a little ball bearing, you could measure the time, and it'll come out, you do your time versus length equation and all that kind of stuff, and pi will equal 4, which it shouldn't. Okay, this circumference will eat up velocity. And that's the whole point. It eats up velocity. Okay, because the only way this thing can turn is it actually has to use its own velocity to make the turn. All of the force, friction, all of the force bending its motion is actually a force coming from its own momentum. Its own momentum gets used up going around the loop, and so when it comes out here, it comes out slower. Where in the case of gravity, right, you're doing the same thing, you're making a loop or orbit. The force is external, so your momentum never changes. Now obviously this isn't how you calculate pi explicitly, any circle sort of is pi. But I mean, it's a way of calculating pi is to understand that these are circular orbits, or elliptical anyway. And so in a way you can derive pi by analyzing these things. But the key thing to understand is the velocity of, say, the Earth going around the Sun. The Earth doesn't have to use up any of its velocity. So I could use the race car example. I use lots of examples where if you create gravity to turn the car, that is, you slope the side of the track, then the car can go faster and you'll get pi to equal 3.14, blah, blah, blah. But if you use your own velocity to turn, that is creating more friction to turn, then you're going to screw it up. And that's the simple truth. That's the way to analyze it. Sorry, that's the correct, that's the correct way to understand his mistake. It just is. I'm sorry, but that's the correct way, and I explained the correct thing. So you're being obtuse, in my opinion. Person whose screen name I didn't even notice. I have a slightly off-topic question. If energy and matter are essentially made up of the... No. They're not made up of the same thing. Electrons and protons are elemental. The little bits of force that make up photons and that create magnetism and cause gravity are different. Now, it is theoretically possible that electrons and protons are, in fact, made out of force that's dead or something. But it's real. You're going way too far in assuming. And I haven't defended any such assumption. Essentially made up of the same subatomic components. What really distinguishes them? I mean, clearly one is acting and one is acting upon. So, I mean, I can't make the distinction any clearer. Electrons and protons naturally, okay? An electron and a proton naturally have no momentum, nothing. The little bits of force that make up photons and other energy never stops moving. Its whole identity is its motion. And it basically pushes this stuff around. It actually pushes it. Okay, a little bit of force pushes electrons and protons. So electrons and protons are dead balloons, and force is the wind. Can something be both matter and energy at the same time? No. Thank you. I appreciate your explanations. Obviously, when a piece of matter is moving, it's a piece of force because it's got force moving it. And the fact that the elemental bit, the electron, has more momentum when it's being moved by force is just a fact. Dove. Gary, I recently brought a shortwave radio. Never owned one. I'm going to build an antenna in my backyard. There's something on the radio? News to me. Then I got interested in how radio waves propagate. You think you would do that first. You'd be interested in radio before you get a shortwave radio, especially if you bought one. But anyway, and how certain software frequencies can bounce off the ionosphere, then be received on the other side of the world. So the ionosphere is way out there, so that's a big reflection, so that's why it goes great distances. This I can understand. What isn't clear to me is how some radio waves, such as low-frequency surface waves, there's no such thing as a surface wave. It's all the same stuff. It's all the same as photons. It's all light. There's some light's invisible. It's all light. Alright? So you can imagine that, like, you're seeing visible light. You can imagine infrared being exactly the same thing, except you can't see it, right? Well, microwaves are the same thing, except you can't see it. And radio waves are the same thing, you can't see it. It's traveling the same way. It's rays. It's not waves. Surface waves can follow the curvature of the Earth, which, you got to know intuitively that just doesn't make any sense, right? But all light doesn't curve. It's moving the same speed as light. How can it curve around the Earth? I mean, that's just silly. Come on. The wiki says, since the ground is not a perfect electrical conductor, it has nothing to do with it. You need the conductor, the ground, at the transmission tower. It's essentially just creating, like you do for tricking electrons to fly off of a surface. You trick them. So the radio antenna is basically just tricking the light to leave. And so it needs a ground to do that. But other than that, the ground is completely superfluous. Ground waves are attenuated as they follow the Earth's surface. So they can't follow anything. Once you release them, they're on their vector and they go. You can't make them go somewhere else. A flashlight, the light comes out. You can't make it go somewhere else unless you reflect it off a surface. The wave fronts initially are vertical, but the ground acting as a lousy dielectric. There's only, there's dangerous words, dielectric. The ground wouldn't be a dielectric. It would be a charged plate. Causes the wave to tilt forward as it travels. Well, obviously the wiki page is silly. This directs some of the energy to the Earth where it is dissipated. Now, I would argue that if they did this experiment on the moon, they would find that AM radio doesn't follow the Earth. They follow the moon's surface. And they, if you put a radio station on, what the hell is that thing called where they landed? Eternity something, Sea of Eternity, Sea of whatever. But anyway, and you had another one at the other location. No line of sight, no radio. So unless you have a really tall antenna, you're out of luck. Does this mean that, so that's sort of a clue, I would argue. So I'm just saying the clue is the atmosphere is scattering, okay? And the fact is the atmosphere has layers in it, of density. And it's almost the same as thin films or whatever, how we want. They're almost the same as layers between air and water. The layers are so kind of defined. And what's really happening is you're creating a cheap fiber optic cable. You're reflecting the AM radio off the layers in the atmosphere. Because it's, okay, does this mean that wave is turning because it's dragging along the surface, causing the wave to tilt forward? So again, there's no tilting forward. They're straight line photons, and you can deflect them slightly. So, I mean, I shouldn't really have to draw this, but I will real quick. So all that's really happening is, so you got a curved surface, you got your AM antenna, and you're going to try to receive it over here. And the idea is the atmosphere has these layers, and the layers might as well be like a fiber optic cable, so the energy will essentially just reflect inside the layers of the atmosphere, and therefore they can follow the curvature of the Earth. But they're really not. They're following the atmosphere. And if there was no atmosphere, then your radio waves would just go straight, and you would be out of luck. Any intuition you can demonstrate would be great in future videos related to this, not understanding the attenuation part. Oh, a video. This video's 8-minute mark shows what I'm talking about. Well, I don't know if I want to. You could have put the time code in there. You can capture a video with the time code. 8 minutes. It doesn't look like anything there. All that wavy crap.
Such as air, the vacuum of space, walls. They just don't travel well through very dense materials, such as concrete, water, dirt, or metal. With that in mind,
yeah, well, we already know that about
different
light.
Frequencies of radio waves behave differently as they travel through the air.
Oh, this is it.
Surface waves, also called ground waves, are in effect for AM.
What a strange drawing. What the hell is this? I don't think they do anything like that. That's almost like banking off of clouds or something, which they probably can do. They can reflect off, I don't know how the atmosphere goes for AM radio. I'm not sure about all those kind of details. I'm just saying that obviously the atmosphere does provide a medium that could create reflections. And that's all you need is reflections. Reflections can make your signal go a lot further. So all you really need to do is reflect it. But I'm pretty sure it's just going through the layers of the atmosphere, and obviously the layers of the atmosphere follow the curvature of the Earth, and therefore the signal looks like it's following the curvature of the Earth.
And broadcasting. This is where the radio waves follow the curvature of the Earth and are capable.
So they follow the curvature of the atmosphere.
Of traveling great distances. This only works with low frequency radio waves, up to about 3 megahertz.
Right, so you're just talking about all kinds of radiation reflects off of different surfaces differently. Some things are transparent to UV, some things are opaque to infrared, it's all kinds of stuff like that. So it's just that different media will carry different wavelengths, blah, 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 blah. So I think that's enough of that. I mean, interesting subject in itself, but I think I've already given you enough reason to understand that if you see something bend, if you see a force bend, look deeper, because you're going to find straight lines. You're going to find that it's not really bending, that it's in fact being affected by some other straight line force. Thank you for the review of the video. I appreciate your explanation. People, photons, to this kind of comment can go to hell. I mean, it's quite useless. So this is somebody who's going to sit there and say Ken Wheeler's right, and yet they are not going to demonstrate with anything called evidence or reasoning or logic. Photons are theoretical particles. I mean, theory is a thing. Theoretical is a word that means something. It means you're proposing something. It's kind of like proposing a model. Okay, I mean, saying they are theoretical, like they do not, the theory doesn't intend to explicitly say they're real, is stupid. Why bother theorizing about gremlins, something you know that's not real? Anybody who has a theory and their theory is the unreal thing does something, wouldn't be much of a fucking theory. That's religion. Light is a coaxial circuit, a meaningless rubbish. I mean, absolutely. So they just keep on saying this crap. I mean, he says this coaxial crap. It doesn't mean anything. Demonstrate it with a single experiment showing how this, draw this coaxial circuit. The universe is electric. No, it isn't, retard. This is so obviously stupid in the sense that as soon as somebody says the universe is electric, without a context, clearly the universe is not communicating with electricity because there's no electricity in a vacuum, you retard. Alright, sorry, the angry photographer is right. Well, sorry, no, your comment is vacuous mush. No matter how much much of an arse he may seem to be, it's not just about him being an ass, it's about him saying things that are just overtly untrue. I mean, plainly experimentally proven to be untrue. He's a lying sack of stupid shit. Alright. But fuck you. Oh, fuck this guy again. So I gave this guy fair warning, right? I explained how I'm here to do two things. Defend my theory and attack conventional. I'm not here to explain to tinfoil hat loop-de-doo nutters who have decided they're going to call something a feragremlin or something, or a mega gremlin, or I don't know, a sissy poo. That sissy poos exist in the universe and that the sissy poos are doing something. I'm not here to debunk your silly sissy poo theory, fuckhead. Anyway, they've built a house of cards based on ill-conceived concept. Yeah, well, their concepts are closer to reality than your loop-de-doo nutsy sissy poo shit. Of a photon, quote, which is just the unit measure for the average spark intensity. I'm sorry, that is a crayon description of physics. I mean, it's water-soluble, edible crayon. It's so fucking immature, so silly. There's no spark, asshole. So the elemental function is not spark, douchebag. Okay, aka brightness length, which means absolutely nothing. Just gibberish words measured in meter candles. Fuck you. We have lasers now. We don't need to measure things in candles, fuckhead. They have defined the associated length as a wavelength when it really is an average interaction distance in an eye volume area. No, we already understand frequency and wavelength well enough to understand it's a timed circumstance, and the speed of light is a really nice, reliable constant. You're just so full of fucking shit. Okay, it says here, photon does not equal wave or particle. Photon equals intensity of sparks. Sorry, you're a fucking idiot. And that's just, it's such childish gibberish. Why do you think anybody would sit there and say, oh yes, I love that fucking spark theory? That's really, really clever. No, it's stupid. So, get a new jargon if you think you're going to persuade somebody with that baby talk. So, fuck off till then. Oh, God, I hate people. Before Baldy Cats pulled out of the bait, you said you were talking to another scientist who seemed to be willing to have a conversation. Yes, and he just kept dragging it out. I kept saying, well, take your time, no pressure. But he kept saying he wanted to get up to speed and all that stuff. And I told him, look, I'm paying you $50 an hour to do the video, but I'm not going to pay you for your research time. And he was okay with that. But he wanted to know, be sure, I guess. And then he never, I gave him rope and he took it all. And so he just never got back to me, ever. Did he back out as well? Yes, he resigned from responding. Are you still pursuing physicists from other university or schools? Well, I haven't done anything recently in terms of harassing anybody, but I'm certainly going to try to persuade people and inform people that, if you have a substantial YouTube channel with more than 100,000 subscribers and you think I'm an idiot and you'd like to prove it, I'll pay you $1,500 to take your best shot. So give it a shot. It's at least a way of avoiding all the YouTube baggage. Well, it's reality baggage, frankly. The baggage is in the human race. It isn't YouTube's fault. The whole fucking world is clearly full of human baggage. Human, stupid fucking human tricks all over the fucking place. Most humans are stupid fucking bags of crap. That's the thing to overcome. On Agree to Disagree channel the other day, Katz did briefly mention, I heard about this, the debate getting canceled last month. He then asked viewers in the chat whether they thought it appropriate to have a debate on the Holocaust, right? So he starts this debate channel, as a derivative. All these guys do this derivative channel thing, and it's just for money. The more channels they make, the more, money they can make. And so he did this whole debate thing, to glom off his meager success, or relatively, he's had success with his little conspiracy crap. So he starts off with conspiracy cats, then he turns it into baldy cats, and now he turns it into debate cats. And where's the science going? Oh, the science is getting looser and more distance. The further you go from the source. And so now it's just a desperate effort to be controversial. So the very thing he said I was too controversial, which is just too funny. But now he's willing to have a debate about the Holocaust? What a joke. Hilarious. He wouldn't debate physics with me, but he would debate the Holocaust with me? It just doesn't make any sense at all. And the response was mixed. Well, I go ahead and do it because you will lose, okay? Anybody who plays with that third rail, there's no way to win, okay? So fuck it. So if they do ever have that debate, then I suppose there's no reason not to give DraftScience his debate on the double slit experiment. Well, the reason is he won't do it is because he's sure to lose that debate. In the Holocaust debate, he would just sit back and be moderator. I'll pretend to know the truth and tell the two participants how far they can go. Just too stupid. Alright. So that's it for the comments, it would appear. So this was a kind of, no, this isn't it. I think this is, no, that's not it either. This is it. Alright, 6,686,972 views. A preposterously large number of views for a real piece of crap, video. So this is some kind of whatever this is, Kurzgesagt. I guess that's some sort of German thing. I don't know what the fuck it is. But it somehow must mean in a nutshell, I guess. Don't really know. I don't know anything about this channel, except the video is stupid. so we'll play it. So it's going, what is a photon?
Connection between us and the universe. Through light, we can experience distant stars and look back at the beginning of existence itself. But what is light?
Oh, just make it all sound so fucking important and interesting. Unfortunately, this is I have to update everything on this older computer because it's not going to update Firefox unless I reload Firefox. So I can't do that little video, pull the video out thing, which is kind of a nice feature. But you can live with this.
Light.
Really cool intros.
In a nutshell, light is the smallest quantity of energy that can be transported. A photon.
Okay, so this is the tricky rhetoric, right? So this will never get fixed until... See, there's just stuff they're just... they're not interested in fixing because they don't know the right answer. But I mean, clearly this what is a photon thing you have to understand it's not as simple as just saying, well, a photon is like a thing. Or it's like a wave, When clearly the problem is how much of a wave, because to say this is a photon, it's a wave, but it's only going in one direction. Is it 3 of these things? Is it 5 of those things? 9 of those things? 20 of those things? What the hell? So, I mean, that very notion that photon should have a name, it should, that you call it a photon when you're really just describing receiving. How do you receive energy that we call a photon? And you receive it by causing electrons to move, okay? And more than one of them has to do it for there to be electricity. So you have to cause a little cascade of electron, and you cause an electric current, and that's a photon in the sense that you triggered it with events. And so I mean, a photon has to be understood. Like I said, even if you do this wave thing, you have to understand it. I'll just put my little things here as just being where the nodes are. So we agree it's composite. It's a certain amount of something, a certain amount. Now, to have a frequency, you have to have at least 2. So it's got to be, more than 2 bits, 2 or more, right? You have to have 2 or more bits. You have to have 2 or more components, wave, to be able to define this event, for this event to have any frequency. Well, see, I guess you could do it this way, but they'd never draw it that way, so that must not. If photons were that, if photons were just this, they'd draw it that way, right? They'd say photon, right? Just one little wavy thing, photon, and we'd be done. But we know they don't do that. And then again, the polarization is saying to you so obviously, it's just like antenna polarization. So it's just like radio. Okay, I mean, obviously it's the speed of light. Something's traveling. It's shooting bits. Okay. It sort of goes the opposite, right? I mean, yeah. The first bit fires, and then the second bit fires, and the third bit fires, and the fourth bit fires, and the fifth bit, And so you can see the polarization there. You see why antennas would have polarization. The first bit of the energy would be way ahead of the other bits, the other electrons being moved. This electron moved first, then this one, then this one, then this one. And you can understand how that would create a frequency, and it would create the polarization. And that these two things would be proportional. And that would be a photon. And then again, the photon is gigantic. Thousands of atoms of polarization, and they never deal with that. How could it affect one electron? How could one electron produce it? Can't be done. These are the facts that they just never compile. They never sit there and do one of these videos and point out, these are the facts about a photon. It has polarization that's large. It has energy, discrete bits that are small. These are facts. But see, they can't do that because their wave model doesn't work. It's hard to understand your wave model as discrete bits, okay, that create a large wavefront.
Photon an elementary particle without a real size that can't...
Okay, so it's not an elementary particle. It's sort of the obvious argument is it's a composite particle. The bits that make up the photon, they're elementary. The wave fronts are elementary. The collection of wave fronts isn't. To put it in your language.
Can't be split, only created or destroyed. Light also has a wave-particle duality, being kind of a particle and a wave at the same...
So that's kind of just mushy. That doesn't make any sense. It's never both of them in the same experiment. So it's never both of them at the same time. So it's just kind of silly to do this mush. You know, as I'm pointing out, the particle model works to answer all the questions. The wave model doesn't. So it's the wave model that has the weakness. That's the one that can't explain. That's the one they should dispose of.
In time, although this is a lie. Also, when we say light, we actually mean visible light.
So he can say things are a lie. But if I said it, oh dear, what a horrible offense. So he thinks it is a wave and that particle duality is a lie. So he's saying it is, but it isn't. I'm suggesting to you this is what we believe, but we really don't believe it. I mean, they're overtly lying, deceiving, talking gibberish while they accuse others of being unclear.
Which is a tiny part of the electromagnetic spectrum, energy in form of electromagnetic radiation.
Kind of funny how they do the spectrum exactly the opposite of how I saw it when I was a kid. I mean, when they did it when I was a kid, you went from lowest energy, that is longest wavelength, to shortest on the other side. And now it's exactly backwards. And I'm like, what the fuck? Blue, purple, like, you know, it's exactly backwards. When did they change the idea? When did they decide that you start at 1,000,000 and go down to 0? I mean, it should start with the 0 energy and go up to the most energy. I mean, it's just so strange.
Electromagnetic radiation consists of an enormous range of wavelengths and frequencies. Gamma rays have the smallest wavelengths because they're the highest energy photons.
So again, it's just a word. Gamma ray doesn't say anything because those are just the ones of frequency that we can't detect. We can't in any way... you know, it's way past X-rays. So you'd really say they're hard, very hard X-rays is, you know, pretty much the answer.
But most gamma rays are just under 10 picometers, which is still way smaller than a hydrogen atom. For reference, a hydrogen...
Yeah, so understand that, so when they do these comparisons that a red light, the polarization of red light, the frequency of red light would be 1,000 or 1,500 atoms across. So this is very small compared to an atom, but red light's really, really big compared to an atom. 1,000 times bigger. 1,000 more, 2,000 times bigger than an atom.
Hydrogen atom compared to a cent is about as big as a cent compared to the moon. Visible light is in the middle of the spectrum, in the range of about 400 nanometers to 700.
Right, so you should use that as an example, okay, and compare that to an atom. But clearly right here you can see it, 700 nanometers, a bacterium you know is made out of thousands or millions of atoms. So clearly very big. How does this thing as big as a bacterium, right, a wave as big as a bacterium, how does it affect one electron? See, I mean, right here, their own drawing is illustrating it to you so clearly. How is it possible this big giant thing has a relationship with one electron? Not possible. You can't even imagine how it has a relationship with one atom, let alone one electron.
100 nanometers, about the size of bacteria. On the other end of the spectrum, radio waves can be up to 100 kilometers in diameter, while the biggest...
Right, and again, doesn't this all bow against this idea that it's some continuous wavy thing? Doesn't it make a lot more sense to realize that I could fire a gun and I could shoot bullets at once an hour? I could shoot bullets once every 30 minutes. I could shoot bullets, you know, bang, every 15 minutes. I could do it every 5 seconds. I could do it every second. I could do it every tenth of a second. Bullets makes sense. Bullets explains all of those different frequencies, where waves ends up being, what the F are you talking about? Even an ocean can't do that. I mean, create these long waves. I mean, it just, the system would break down, and it's the amount of energy that would be in your very long waves would be insane.
Wavelengths we know exist can span from 10,000 kilometers to a baffling 100,000 kilometers, way larger than Earth. From a physics standpoint, all these different waves are the same. They all have the...
There you go. See, that's the part to understand. It's all the same thing, and what fits for all of this same stuff? Bullets. Bullets, bullets, bullets. Bullets explains it all.
The wave-particle duality and travel at...
Again, why is this weird drawing where you draw the object first and then have them moving in a direction? It's not even... I mean, they're pretty animations, I suppose, but they're not very coherent.
C, the speed of light, just at different frequencies.
So again, that fits with the bullet theory. That's it, right. So they're flying the same frequency, they're shot out of the same gun, same load of gunpowder, same thing. And all you're doing to change one thing to another, you're using the same bullets, you're just changing the firing rate.
So what makes visible light special then? Well, absolutely nothing.
Yeah, I don't know if that's actually true. It seems to be the amount, the thing the sun produces the most of, first off. And there's lots of things, about this radiation. It has a really good, dangerous to resolution. I mean, the longer the wavelength, the less resolution you're going to get, the less you'll see. Okay, like even the frame rate. I had trouble getting this frame rate right. The more, detail you can see. So there's a nice exchange you have, between the danger of the radiation, that is its capacity to ionize atoms, and how much resolution you're getting out of it. So, this is the kind of radiation you want to play with in the visible range. If you go to infrared, you don't see as much detail.
We just happen to have evolved eyes that are good at registering exactly this part of the electromagnetic spectrum. This is not a complete coincidence, though. Visible light is the only set of electromagnetic radiation that propagates well in water, which happens to be where most eyes first evolved.
Well, he should say all of the spectrum of visible light, right? Because it is a spectrum. Is there anything else to say to that? I don't know if ultraviolet, how well it travels, frankly, in water. Never tested that one.
Evolved millions of years ago. That was a smart move because light not only interacts with matter, it's also altered by it and can be used to gather information about the world around us with almost no delay, which is arguably really helpful for...
So he never should say no delay. I mean, obviously, light moves at the speed of light. There'll always be a delay. And again, light is a time-dependent object. It never arrives at an object. Photon! No, it takes time because it's at a frequency. It takes time for the substance to record being hit by a photon. A certain amount of time it takes for each element of the photon to reach the object and make the object do the thing it's going to do. And the object is going to be something bigger than a single electron or a single atom even. It's going to be crystals and metals, for example. The most common way to detect photons is to have them affect the crystals on a metal and create electricity.
For survival. Okay, where does light come from? A vast range of electromagnetic waves are created when atoms or molecules drop from a higher state of energy to a lower one.
So atoms or molecules are now doing this dropping from states of energy. When we know, no, that happens only inside of individual atoms. Molecules don't have energy states.
They lose energy and emit it in the form of radiation. At the microscopic level, visible light is created when an electron within an atom, that is, in an excited state, drops to a lower energy state and...
So we just showed the little thing flying off. Now, do you think that's a photon? Do you think that's 6 or 7 of those wave fronts? Or is it just 2? Or is it just 1? And the question would be, obviously one event, moving one electron in one atom, ionizing one atom, is just going to create 1 bit of a photon. It's not going to create a photon. It's not going to create the frequency. It's not going to create event, 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 event. That's what you need. You need more than 1 event to create a photon.
Loses this excess energy. The same way incoming light can elevate an electron to a higher state of energy by...
So again, a electron, incoming light. Well, pieces of the light can do that. Each little quanta can cause an electron to move, but you have to move more than 1 electron to recreate a whole photon. And that's why there is a dependency to see light, to have it reflect off of atoms.
Being absorbed by it. Macroscopically, the moving charge of the electron creates an oscillating magnet field, which...
So this is all just crap. They made up this drawing. There's no real evidence that there's either one of these fields even exist. They've just used them as placeholders for the truth. They don't have any definition. They have no way to analyze them. There's obviously nothing about photons that seem overtly magnetic in the sense that you can't bend them with magnets. There's nothing about them that's overtly electric besides the fact that they move electrons. So of course they have some connection to electricity, because electricity is about moving electrons in atoms, that is, conveying from one atom to another an electron. That's the nature of electricity. There is no electricity in space because there's no atoms to exchange electrons. I mean, come on, this is dissectable. The truth is, this is obviously not the right answer. It's such a flawed diagram.
Which creates an oscillating electric field perpendicular to it. These two fields move themselves through space.
These two fields, there's not even a field here. They're not showing you anything. These squiggly lines of magical, of something. We don't even know what this represents, this amplitude. Does that represent compression? What is that? What is it? The jello gets thicker, the jello gets thinner. What does this even mean?
Transferring energy from one place to another, carrying information about its place of creation with it. Why?
No, they're just bullets, like these little cars. They're just little cars in order, in a row, and their polarization is a little bit of out of alignment. They're running on different rails of the track, and they arrive at a wall and they smash into it. And if they smash into the wall with the right frequency, they tip the wall over.
Of all the things in the universe, is light the fastest thing there is? Let's check.
So let's understand it. So again, it's someday physics is going to acknowledge that they should call it the speed of force, because all the elemental forces, magnetism, gravity, electricity in a perfect conductor, and light, all travel the same speed. It's the speed of force. It isn't the speed of light. This is as obvious a mistake as, Ben Franklin getting plus and minus backward. To call it the speed of light because Maxwell assumed, that everything's a derivative of light, when no, light's a derivative of force.
Change the question. What is the fastest way to travel through space in the universe? It's c, exactly 299,792,458 meters per second.
Right, the same speed charge moves, the same speed gravity moves, the same speed all of the elemental mechanisms that cause momentum to move from one object to another move.
In a vacuum, 1 billion kilometers per hour. Electromagnetic radiation just happens to move this fast.
Okay, so it just happens. It's exactly the opposite description. Light just happens to be made out of the same stuff all the other forces are made out of. They're not magical fields, they're actual forces. There's actual soldiers. This is how fast soldiers run. Period. The bullets have a standard speed. You can arrange the bullets in different ways and then call it a different thing.
Any particle that has no mass travels at c, without acceleration or any in between. The light that's being released from a candle does not speed up until it reaches light speed. At the very instant of its creation, its speed is c.
Right, the force is always the force, and all you can do is trap it and release it. So it's like a hummingbird that never lands. Actual hummingbirds do. But let's say you had a bird that has no legs, can't stop. You catch it in a cage. You put the cage in your car. The bird still has to fly around at its speed, 50 miles an hour, let's say. And it doesn't care whether you're going forward or backward or this way or that way. That just changes where the bars on the cage are for the bird. Bird's always going 50 miles an hour, and so you can go 600 miles an hour. And when you open the door to the bird cage, the bird's only going 50. Now, when you're going 600 miles an hour, I guess the bird was pretty much smashed up against one side of the cage. But the point is the bird only has one speed. And the force always has one speed, and all you can do is let it go.
So why is c, or the speed of light, finite then?
The speed of force, again, I didn't know it was going to get into this bullshit.
Well, nobody knows.
This has nothing to do with what a photon is.
The universe is just built this way. We don't have a smart answer here.
Oh, gee, we don't. Oh, man. Nothing to say. The interesting thing is they got a hexagon here, right? But the five-sided shape is interesting. I'm thinking I'm going to use that. But anyway, it's a whole nother story.
So light is a part of a spectrum, an elementary particle that also behaves like a wave, propelled by two perpendicular...
It doesn't behave like a wave, and it's only their fantasy, and they're forcing it to fit in the most bizarre cases because they quote mine the evidence, and they've ignored all the evidence saying, no, it really isn't like a wave. They even ignored Feynman saying it.
Particular fields traveling at the speed limit of the universe. Okay, that's nice and all, but what about all the crazy stuff about traveling at the speed of light and time, the twin paradox, quantum stuff, and things like that? We have to save them for another video. For now, let's just be happy that we evolved eyes that pick up waves of information permeating the universe.
Waves of information again. Yes, rays that get into our telescope. I mean again, it's waves what? So you think the same stuff is going everywhere and it's just here in your telescope? I mean, come on. They'll even admit this. They know that when you get further and further away, you either get hit by a whole photon or no photon. There is no continuous wave where you can just grab the wave at any location and the same wave bar is flying through space. No, it has every appearance of being a clump. Spitballs, mud, speckles, water droplets. There's so many ways you could analogize this. It has nothing to do. I mean, no one would say the rain, it's a wave of raindrops or something. Come on.
But making us see things that help us to put our existence into perspective.
Right, and you got all those things wrong, and so you have a horrible perspective, and you really don't have a clue, and you really are all dumbasses, and you're just such an embarrassment to our capacity to be intelligent, because intelligent people scrutinize, they pick at things they want, and especially ones who want the truth. They question, and you people question nothing. You just recite your Bible. Oh, give us this, give us that. Patreon, fuck, shit. Pay them for being wrong and juvenile and simplistic and patronizing. Patronizing. Hey, I didn't realize there was a connection there. Patronizing. So anyway, Alright, so hopefully this is a video, and hopefully I can find a new routine and get over the trauma of losing everything. You know, just the whole hard drive. It's just dead. I should have it right here. Where is it? This was the other one that didn't work. My other Linux distribution of Mint. It should have worked. It was the copy I made that doesn't work. That's another thing that Linux does very well, is fails to make copies that work. Oh yeah, I tried plugging it in a USB port to see if I could get it to work. So I'm not going to unplug it. But anyway, I mean, I got whatever 4 years out of it. I shouldn't really complain. You know, I paid $20 or something, 15. So I really don't have a right to complain, but I'm still going to complain because it sucks. It's irritating. Hard drives is just irritating. You lose a hard drive. Just, ouch. So anyway, I mean, I have a lot of stuff to reload, blah, 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 blah. Anyway, but I might keep this, like I said. So this is impossible almost to copy, though, which is really irritating, too. You know, because it just is, it's too buggy. You make a copy and neither copy works. You know, that kind of thing. It's just too irritating. So anyway, till the next time, such. Okay, now hit the right button, Gary. Let's just save it. It has a nice icon in this thing too, which is kind of nice. I mean, not that icons matter, but it's, you know, much nicer icons. This should save, and I should be making a video.